Here we're asked to use the factor theorem to see if the polynomial x plus 4 is a factor of the larger polynomial p of x equals x cubed minus 13x plus 12. So here's what the factor theorem says. If we synthetically divide a polynomial p of x by a number c and we get a zero remainder, that means that x minus that c is a factor of the polynomial p of x. Okay, so in this case we're going to synthetically divide the polynomial p of x, which is x cubed minus 13x plus 12, by x, well let's see, they want us to find out if x plus 4 is a factor. So what number c is being subtracted from x? We need to see it as x minus c. So in order to see it that way, we just have to, well, let's set up our division. Here's our coefficients. Look, there's a missing power of x. X to the second power is missing, so I put 0. Now you see what we did? We rewrote the x plus 4 as x minus a negative 4, the double negative. That way we know what the c value is. C is always a number being subtracted from x in this type of problem. So the c is negative 4. We're going to synthetically divide by negative 4. Bring down the first number and multiply negative 4 times 1. That's negative 4. Add. Multiply negative 4 times negative 4 is 16. Add, we get 3. Add, we get 0. And we're having a party because we got a 0 remainder. And that means that x minus the c that we just divided by is, in other words, x plus 4, is a factor of the denominator, of the numerator. The numerator is the p of x. All right, it's a factor of p of x. Okay, what else does this mean? It means that the c value in x minus c is a root or a 0 of the polynomial p of x. So that means that, let's see, what is the c value? It's negative 4, and that is our root or our 0 of the polynomial. So we get lots of information here, and we do it by synthetically dividing the polynomial by a c value. If we get a 0 remainder, we have a party, and we state that x minus that c is a factor of the, it's a divide, how shall I say this? It is the p of x is divisible by x minus c. Yeah, that's what I'm trying to say. And we also say that the value that we synthetically divided by is a root of the polynomial p.